So our most recent edition of Quadratics dealt with quadratics in factored form. So factored form was a little bit different than any of the other ones we looked, but it should look somewhat familiar to you because it looks like this. It's y equals x minus a times x minus b. And these two pieces here, x minus a times x minus b, those are our factors. And we have been factoring, so the way this appears should not look strange to you. We're just going to learn how to work with it. So this is just a little bit of a reminder about what everything does. So when you have something in factored form where it's like y equals x minus a times x minus b, this is going to give you your x-intercepts, your zeros that comes from the a and b. When you have this equation in standard form, your y-intercept comes from the c value, which is the number that's by itself, the number without x. Your axis of symmetry, you use the b, which is the number in front of x, and a, the number in front of x squared, to find out that axis of symmetry. To find the vertex, you use that same number you got here from the axis of symmetry, and that gives you half your vertex. To find the other half, you plug in that value you got and see what you get out for y. And that value that also gives you your minimum or your maximum. So when you plug that number in, it gives you your min or your max. And the way you decide if it's a min or maximum, and the way you decide on your range, is if your graph opens up or if your graph opens down. If it opens up, the number here at the bottom is your minimum. And if it opens down, then the value here at the top is going to be your maximum. And so if that's your maximum, then your range is y's that are less than or equal to. If it's a minimum, your range is y's that are greater than or equal to that value. So if I have y equals x plus 3 times x minus 5 and I want to find my x-intercepts, well, all I have to do is take my plus 3 and my minus 5, and I'm going to switch their signs. So my x-intercepts are negative 3 and positive 5. And my zeros are also negative 3 and positive 5 because my zeros are the same thing as my x-intercepts. So now I need to find my standard form. So standard form. So the next thing I need to find is my standard form, which means I need to take my factors of x plus 3 and x minus 5. I need to multiply them out. Well, x times x is x squared. X times negative 5 is negative 5x. 3 times x is 3x. And 3 times negative 5 is negative 15. I can combine my negative 5x and my positive 3x together, which really gives me x squared minus 2x minus 15. I'm going to set that equal to y because that's what my original equation was equal to, and this is my standard form. So to find my y-intercept, well, my y-intercept is easy to identify from my standard form because my y-intercept is the number that, when it's in standard form, is by itself the number that's without x. So my y-intercept in this problem would be negative 15. So I'm going to write that as the ordered pair 0, negative 15. And that would be my y-intercept. The next thing I'm looking for is my axis of symmetry. Well, to find my axis of symmetry, I'm going to use the formula x equals negative b over 2a. So in this formula, x equals negative b over 2a, b is the number in front of x, and a is the number in front of x squared, which in this case would be a 1. So I'm going to plug in this equation, so it says negative. Instead of b, I'm going to put negative 2 there, divided by 2 times, instead of a, I'm going to put 1. Again, the a came, or the negative 2 is there because that was the number in front of x, and the 1 is in the bottom because that was the number in front of x squared. And so then I just have to do a little bit of math, and negative 2 is really positive 2, divided by 2 times 1, which is also 2, and 2 divided by 2 is 1. So my axis of symmetry is x equals 1. And when I know my axis of symmetry, I also know half of my vertex. I know the x value of my vertex. To find the y value of my vertex, I need to plug that number in. I need to plug 1 back into my original equation. So remember, for my axis of symmetry, we found out that x was 1. So that means that we're going to replace my x values here with a 1. So I'm going to rewrite this as, instead of x, I'm going to do 1 plus 3 times 1 minus 5. Well, 1 plus 3 is 4, and 4 minus 5 is negative 4. And when I multiply, 4 times negative 4, I get negative 16. So that gives me the other half of my vertex. That gives me the y-coordinate of my vertex. That's where this number comes from. That also tells me something about my range, because my range is always y's that are either greater than or equal to that y value from my vertex, so that negative 16. And the way we decide if it's greater than or less than is we have to figure out which way does the graph open. So if I were to graph x plus 3 times x minus 5, well, notice everything, like my x's here, both positive, and when I worked this out and I multiplied this, and I got 1x squared plus minus 2x minus 15. That x squared was a positive x squared, so that tells me that my graph, when I graph this, is going to open up. And if that graph opens up, that means that my vertex is my minimum point. It's down here. It is my minimum, so my graph is everything above that. So it's y's that are greater than or equal to negative 16. And the very last thing is that my domain, which is always for all of our functions that we're dealing with, is all real numbers. And that just means that my graph continues to grow. It never stops growing. Also, don't forget, because it asks for this on your homework, your vertex, in this case, was our minimum value. It was our minimum, and the reason it was our minimum was because it was at the bottom of our graph. It was down here. So I first have to identify the x-intercepts of my function. Well, my x-intercepts come from the numbers in the function. So notice that this first part just says x. That means I have an x-intercept of 0. So that's easy to figure out. The second one's a little more complicated because usually our x-intercept is simply this number here. But notice there's a 3 in front. We've never had one, like we haven't seen one at least, that has a 3 in front. So my x-intercept isn't just positive 7, it's actually positive 7 divided by 3. So I still flipped my sign here, but then I divide by the coefficient of x. So my zeros are also 0 and 7 over 3. To find my standard form, I need to take my equation, which is y equals x times 3x minus 7, and I'm going to distribute. I'm going to multiply x times 3x, which is 3x squared, and x times negative 7, which is negative 7x. I can't combine anything. I can't do anything else with that, so my standard form is 3x squared minus 7x. My y-intercept comes from the number that's added on the end. Well, there's nothing added on the end, so that means that my y-intercept is 0. So it's the ordered pair 0, 0. So my axis of symmetry, to find that, I use the formula negative b over 2a. Remember, b is the number in front of x, and a is the number that is in front of x squared. So that's going to be negative 7, or negative 7, I apologize, divided by 2 times 3. Well, the negatives are going to cancel, and I'm left with 7 over 6. I can't do anything else with that, so I'm going to leave it. So my axis of symmetry is x equals 7 over 6. That's also half of my vertex. To find the other half of my vertex, I need to plug this in, 7 over 6, into my original equation, which was, again, y equals, instead of x, I'm going to plug in 7 over 6 times 3, and again, instead of x, I'm going to plug in 7 over 6 minus 7. And I would use the calculator to figure that out. And it gives me y equals negative 49 over 12. So a pretty ugly number there. But what that now tells me is that tells me the other half of my vertex. That tells me the y value of my vertex. So negative 49 over 12. That also tells me my range. My range is always y's that are greater than or equal to or less than or equal to the y half of the vertex, and it depends on if my graph opens up or down. So if you'll look back here, it says my a value is positive 3, so that tells me my graph is going to open up. So that means that my range is y is greater than or equal to. It also tells me my vertex is my minimum point. And my domain is always all real numbers.